Hello, in this lecture I will answer two questions. In the first question we find out the length of side AB of this right triangle ABC. The second question we find out the area of this square ABCD, and we have to find out also the length of this tangent QP. So we start with the first question. In the drawing we have a circle that is inscribed by this right triangle ABC. This is an angle ABC, that is right angle. You know that side BC of this triangle ABC equals to 40 units in its length. And we also know that the radius of this circle equals to 4 units in its length. Again, our test is to find out the length of side AB of this right triangle ABC. So first of all, we define the relevant point to this question with letters. We define the center of this circle. This point is point O. We will define the point of tendency of tangent AB with this circle. This point is point D. We define the point of tendency of tangent BC with this circle. This point is point E. And finally, we define the point of tendency of tangent AC with this circle. This point is point F. The next step, we will join points O and E together by straight line. Point O is the center of the circle, point E is the point of the circle itself, therefore OE is the radius of the circle, is equals to 4. The radius OE is equals to 4, the radius OE is 1 to point E, that is the point of tendency of tangent BC with this circle. Whenever your radius is 1 to the point of tendency, then tangent BC will be perpendicular to the radius EO. If BC is perpendicular to EO, it means that this angle equals to 90 degrees inside, and this angle also equals to 90 degrees inside according to rule 1. Likewise, we join points O and D together by side line. OD is of course the radius of this circle, equals to 4 units. The radius of D equals to 4, the radius of D is 1 to point D, that is the point of tendency of tangent AB with this circle. Whenever you have a radius that is 1 to the point of tendency, then tangent AB will be perpendicular to the radius DO. If AB is perpendicular to DO, then this angle equals to 90 degrees in size. This angle also equals to 90 degrees in size according to the same rule, rule 1. So in the small quadrilateral ODBE, we have 1, 2, 3 right angles. The sum of right angles is 270 degrees, so 270 degrees plus the size of this fourth angle, in total must become to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth angle must be equal to 90 degrees in its size. So in quadrilateral DOEB we have 4 right angles. Therefore, we can relate to quadrilateral DOEB as right angle. But we also know that the opposite sides of rectangle are equal to each other. So in the small rectangle DOEB, side DO must be equal to the opposite side BE. But DO is 4, therefore the opposite side BE must also equal to 4 units in its length. Likewise, according to the same rule, in the same small rectangle DOEB, side OE must be equal to the opposite side DB, but OE is 4, therefore the opposite side DB must be also equal to 4 units in its length. So in total we found out that quadrilateral DOEB is not a rectangle but a square. Why? Because of the fact that all of its sides are equal to each other. Each side equals to 4 units in its length. What is the length of this missing line 7 EC? EC equals to BC minus BE. So you know, EC equals to BC minus BE. So EC equals to BC is 40 units in its length according to what's going in the question. Minus BE, B equals to 4 units in its length. So in total EC equals to 40 times 4, that is 36. EC equals to 36 units in its length. Here we can implement rule 2 in our drawing. We'll repeat quickly on rule 2. According to rule 2, the lengths of two tangents from a common start point to a circle are equal. So in the drawing, you have a circle. This is the common start point, point P. From this common start point, point P, we have two tangents to this circle, tangent PA and tangent PB. According to this rule 2, they are equal to each other. That is to say, PA equals to PB. So we can actually implement rule 2 in our drawing. We focus on this common start point, point C. From this common start point, point C, we have two tangents to this circle, tangent CE and tangent CF. And according to rule 2, they are equal to each other. That is to say, CE equals to CF. But we only found out that C equals to 36 units in its length. Therefore, CF must be also equal to 36 units. According to rule 2. Likewise, we focus at this common start point, point A. For this common start point, point A, we have two tangents to this circle. Tangent AD and tangent AF. And according to rule 2, they are equal to each other. That is to say, AD equals to AF. So if you define the length of AD as x, then AF must be also equal to x units in its length according to rule 2. So we will implement the Pythagoras theorem on this big right triangle, triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse of this right triangle ABC is AC, so it is AC square equals to AB square plus BC square. So in the norm, AC square, this is the square of the hypotenuse, equals to AB square plus BC square. And again, in this right triangle ABC, according to the Pythagoras theorem, the following equation is solved. AC square equals to AB square plus BC square. AC in total equals to x plus 36, therefore AC square equals to x plus 36 square. And it equals to AB square. AB is x plus 4, therefore AB square is x plus 4 square. Plus BC square. BC is 40, therefore BC square is 40 square, that is 1600. So in total, we should find out that x plus 36 square equals to x plus 4 square plus 1600. Here we'll open the brackets on both sides of this equation, and we get that x plus 36 square equals to x square plus 36 square. 36 square equals to 1296 plus 2 times x times 36. 2 times x times 36. 2 times 36 is 72, so it is 72x. And it equals to x plus 4 squared. X plus 4 squared equals to x squared plus 4 squared, that is 16, plus 2 times x times 4, that is 8x. Plus 1600. So here we have x squared on both sides of this equation, so x squared will get cancelled. After you cancel x squared, in this side of the equation we have only 1296 plus 72x equals to 16 plus 1600 is 1616 plus 8x. Here we'll subtract 8x from this equation. So here 8x will get cancelled, and we have only if 1616 in the side of the equation. And on the other side of the equation we have 1296, and we have 72x minus 8x is 64x. So in total we found out that 1296 plus 64x equals to 1616. Here we subtract 1296 from this equation. Inside of the equation 1296 will get cancelled, and we left only with 64x. Well, on the other side of the equation we have 1616 minus 1296 is 320. So in total we found out that 64x equals to 320. So here we divide this equation by 64 and get that 64x over 64 is x equals to 320 over 64 is 5. So in total we found out that x equals to 5 units in its length. Our task is to find out the length of this side AB on this side ABC. AB in total equals to x plus 4. X is 5, so AB equals to x that is 5 plus 4. 5 plus 4 is 9. So in total, if you found out that the length of side AB of the right side ABC is equal to 9 units. The length of this side AB is equal to 9 units. So we finish with the first question. The next step, I will present to the second question, and we'll solve the second question of this lecture. In the second question, we have two tasks. The first task is to find out the area of this square ABCD, and the second task is to find out the length of this tangent QP. So in the drawing, we have a quarter circle and a semicircle that are located inside this big square ABCD. The quarter circle and the semicircle touch each other externally at this point. So we define this point is point K, that is their touching point, or the point of tendency of them. We also know that the radius of this semicircle equals to 17 units, the radius of this quarter circle is equal to 36 units in its length. So first of all, we define the relevant points to this question with letters. We define the center of this semicircle, this point is point O. We define this point as point E. We define this point as point F. We define the length of this short line segment EB as X. And we define the length of this short line segment FB as Y. What is the definition of line segment DF? Point D is the center of the quarter circle, point F is the point of the quarter circle itself, therefore DF is the radius of this quarter circle. This is equal to 36 units in its length, according to what is given as the question. Likewise, point O is the center of the semicircle, point A is the point of the semicircle itself, therefore OA is the radius of the semicircle, it equals to 17 units in its length. Likewise, OE is also the radius of the semicircle, it equals to 17 units in its length. So So our first test is to find out the area of this square ABCD. So what is the area of square ABCD? Actually, we know that the area of any square equals to the length of one side squared. Again, the area of any square equals to the length of one side squared. So the area of the square ABCD will be equal to AB squared. AB in total it is 17 plus 17, that is 34 plus x. AB equals to 34 plus x. Therefore, AB squared must be equal to 34 plus x squared. So according to the first method of calculation, the area of square ABCD, that is the area that you're looking for this question, is equal to 34 plus x squared. The area of square BCD also equals to BD squared. This is the length of one side squared. To say it is BD squared. So according to the second method of calculation, the area of the same square ABCD is equal to BD squared. BD in total equals to y plus 36. Therefore, BD squared must be equal to y plus 36 squared. So according to the second method of calculation, the area of square ABCD is equal to y plus 36 squared. So we have two different equations for the area of the same square ABCD. Equation 1 and equation 2. Therefore, we will get the equation 3 that states that the area of square ABCD, according to the first method of calculation, must be equal to the area of the same square ABCD according to second method of calculation. Very simple equation. So according to equation 3, the area of square ABCD according to the first method of calculation equals to 34 plus x squared and must be equal to the area of the same square ABCD according to the second method of calculation. The area of square ABCD according to the second method of calculation equals to y plus 36 squared. So in total, according to equation 3, we found out that 34 plus x squared equals to y plus 36 squared. Here we'll take a root out of this equation, and we get that here the root cancels the square, and we left only with 34 plus x. This side of the equation. And on the other side of the equation, we have again the square cancels, the root cancels the square, and we left only with y plus 36. So in total, if you found out that 34 plus x equals to y plus 36. Here we will subtract 34 from this equation. So here 34 will get cancelled. So in this side of the equation 3 we left only with x, while on the other side of the equation we have 36 minus 34 is 2. So in this side of the equation we left only with y plus 2. So in total, if you found out that x equals to y plus 2, according to equation 3, x equals to y plus 2. Here we can implement rule 10 in our drawing. Because of the fact that in our drawing we have the semicircle touches the quarter circle at point K. So they touch each other externally at point K. Whenever you have an external edge between two circles or semicircles or quarter circle, you can implement rule 10. So if you click on rule 10, according to rule 10, if two circles touch each other externally, then the straight line that connects the circles together passes through their touching point. In the drawing, we have those two circles that touch each other externally, this point P. The center of this circle is at point O. The center of this circle is at point N. The straight line that connects the circles together is of course the straight line OM. The straight line OM, according to this rule 10, must pass from point P, that is their touching point. Again, the straight line OM must pass from their touching point, that is point P. Or OPM is one straight line. Again, OPM is one straight line. That is to say, if OPM is one straight line, it means that OM must be equal to OP plus PM. So we can implement rule 10 in our drawing. In our drawing, so as I mentioned before, we have an external edge between the semicircle and the quarter circle at point K. The center of this semicircle is at point O. The center of this quarter circle is at point D. The straight line that connects the centers together is of course the straight line OD. According to rule 10, the straight line OD must pass for the touching point, that is point K. So we join point O and D together by straight line, and according to rule 10, the straight line OD must pass for the touching point, that is point K. And indeed, the straight line OD passes for point K, that is the touching point, exactly according to rule 10. According to rule 10, OD in total equals to OK plus KD. Until now, OD equals to OK plus KD. So OD equals to OK. OK is the radius of this semicircle. Is equals to 17 units in its length. Plus KD. KD is of course the radius of this quarter circle. That is equals to 36 units in its length. So in total, we actually found out that OD equals to 17 plus 36 is 53. OD equals to 53 units in its length. OD equals to 53 units in its length. ABCD is a square, therefore this is a right angle. So in the next step, we will implement the Pythagoras theorem on this right green triangle, triangle OBD. And again, we implement the Pythagoras theorem on this green triangle, triangle OBD. According to the Pythagoras theorem, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in the right triangle OBD, here by PT is the version for Pythagoras theorem. OD squared, that is the square of the hypotenuse, equals to BD squared plus OB squared. is again according to the Badel's theorem, and this green right triangle BD, the following equation is true. All d squared, that is the square of the hypotenuse, equals to BD squared plus OB squared. OD is 53, therefore OD squared is 53 squared, this is 2,809. And it's equals to BD squared. BD in total it is y plus 36, therefore BD squared is y plus 36 squared. Plus OB squared. OB in total it is 17 plus x, therefore OB squared is 17 plus x squared. So in total we found out that 2,809 equals to y plus 36x. Y plus 36x equals to y squared plus 36 squared, this is 1296, plus 2 times y times 36. 2 times 36 is 72, so it is 2 times 36 is 72, so in total it is 72y. Plus 17 plus x squared. 17 plus x squared. Actually, we found that, we continue, we already found out that x equals to y plus 2. X equals to y plus 2. So we substitute x in this expression by y plus 2. So 17 plus x is 17 plus 2 plus y. So in total 17 plus x squared equals to 19 plus y squared. We just substitute x by y plus 2. We found out that 17 plus x is 19 plus y squared. So 19 plus y squared. So in total we found out that 2,809 equals to y squared plus 1296 plus 72y, and we have here 19 plus y squared. 19 plus y squared equals to 19 squared, this is 361 plus y squared plus 2 times 19 times y. 2 times 19 is 38, so it is 38y. So in total, if you found out that 2,809 equals to y squared plus y squared is 2y squared. And we have also 1296 plus 361 equals to 1657. And finally we have 72y plus 28y equals to 110y. So in total we found out that 2,809 equals to 2y squared plus 1657 plus 110y. Here we will subtract 2,809 from this equation. So here we have nothing, that is to say 0. While on the other side of the equation we have 2y squared plus 110y, and we have 1657 minus 2,809 equals to minus 1152. So in total we found out that 0 equals to 2y squared plus 110y minus 1152. Here we divide this equation by 2, and finally get that 2y squared over 2 is y squared. Other 10y over 2 is 55y. And finally, minus 1152 over 2 is minus 657. And again, minus 1152 over 2 is minus 576. Equals to 0 over 2 is 0. So in total, if you found out y squared plus 55y minus 576 equals to 0. So this is a quadratic equation. And the general formula for a quadratic equation is as follows. Ax squared plus bx plus c equals to 0. The general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we'll find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Now a specific quadratic equation, this is to say y squared plus 55y minus 576 equals to 0. The variable that you are looking for is y, so x equals to y. X equals to y. So y is the variable that you are looking for. The coefficient a equals to 1. The coefficient b equals to 55. And finally, the coefficient c equals to minus 576. So we actually have all the data that is needed in order to find out the value of y, that is the variable that we are looking for in our specific quadratic equation. We just have to put the data of our specific quadratic equation inside this general formula for x, and this way we find out the value of the values of y, because y might have two solutions. So we do it now and get that. X equals to y, so sum x here by y is the variable that we're looking for, is equal to minus b. B is 55, therefore minus b is minus 55, plus minus square root of b squared. B is 55, therefore b squared is 55 squared. 55 squared equals to 3025. Minus 4 times a times c. So it is minus 4 times a is 1, so minus 4 times 1 is minus 4 times c. C is minus 576, so minus 4 times 576, minus 4 times 176, in total it is equal to 2304. So it is plus 2304 divided by 2a. A is 1, so 2 times a is 2 times 1, that is 2. So in total we found out that y equals to minus 55 plus minus square root of 3025 plus 2304. So in total we found out that y equals to minus 55 plus minus 3025 plus 2304. In total it equals to 5329. So inside the we have the 5329 divided by 2. So y equals to minus 55 plus minus the square root of 5329 is 73 divided by 2. So in total, if you found out that y equals to minus 55 plus minus 73 over 2. Y is the left of line 7BF, therefore y is the left, it must be a positive number. So we take into account only the positive solution for y. The positive solution for y is as follows. Y equals to minus 55 plus 73 over 2. This is the only solution that is possible for y because y is the left, and the left it must be a positive number. So y equals to minus 55 plus 73, that is 18. 18 over 2 is 9. So in total, if you found out that y equals to 9 units in its length, we already found out that x equals to y plus 2. So x in total must be equal to y, that is 9 plus 2. 9 plus 2 is 11. So in total, if you found out that x equals to 11 units in its length and y equals to 9 units in its length. Our first task is to find out the area of this square ABCD. We already found out that the area of square ABCD is equal to the length of one side squared. Choose side AB as one side of square ABCD, so it is AB squared. AB in total is 17 plus 17 is 34 plus x. AB is 34 plus x. Therefore, AB squared must be equal to 34 plus x squared. But x is 11. So 34 plus 11, 34 plus x is 34 plus 11 squared. 34 plus 11 is 45. So it is 45 square. 45 square is 2025 square meters inside. So if you want to know that the area that we are looking for in this question, that is the area of square ABCD, is equal to 2025 square meters in size. Okay, again, if you found out that the area of this square ABCD, that is the area that we are looking for in this question, is equal to 2025 square meters in size. So we finish with the first part of the second question. The next step, we answer the second part, that is to say, we find out the length of this tangent QP. What is the length of tangent QP? So first of all, we find this angle BDO as alpha. So in this angle BOBD, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees, that is the sum of the angles in any triangle. Therefore, this first angle must be equal to 90 degrees minus alpha. In the drawing, we have tangent QP is tangent to this quarter circle at point K. DK is the radius of the quarter circle. The radius of DK is equals to 36 units in Islam. The radius of DK is 1 to point K, that is the point of tendency of tangent QP with this quarter circle. Whenever your radius is 1 to the point of tendency, then tangent QP will be equal to tangent QP will be perpendicular to the radius KD. If QP is perpendicular to KD, it means that this angle equals to 90 degrees inside, and this angle also equals to 90 degrees inside, according to all one. So in this small rectangle QKD, this angle equals to alpha, this angle equals to 90 degrees, and therefore this further angle must equal to 90 degrees minus alpha. 1 plus 90 degrees minus alpha plus alpha is 90 degrees, 90 degrees plus 90 degrees is equal to 180 degrees, that is the sum of degrees in an angle. Therefore this further angle must be equal to 90 degrees minus alpha. In the next step, we will do a construction, that is to say, from this point P, we will draw perpendicular on BD. Again, from point P, we will draw perpendicular on BD. Okay, this angle equals to 90 degrees inside. This angle also equals to 90 degrees inside according to our construction. We define the touching point of the perpendicular from point P and BD. This point is point T. By doing this construction, we added here the small quadrilateral PTDC. Inside the small quadrilateral PTDC, those two angles, they are both right angles because there are two angles of square ABCD. So, in quadrilateral PTDC, we have, this is the right angle according to our construction. So we have in total 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth thing in total must be equal to 360 degrees. According to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth thing must be equal to 90 degrees in size. So in quadrilateral PTDC we have 4 angles, therefore we can relate to quadrilateral PTDC as a rectangle. Now, this is a rectangle because it has 4 angles. What is the length of side AB of this square ABCD? AB in total comes to 17 plus 17, this is 44 plus x. X is 11, so in total AB equals to 34 plus 11, that is 45. AB equals to 45 units in its length. Therefore, all the other 3 sides of square ABCD must be also equal to 45 degrees in their lengths. That is to say, BD also equals to 45 units in its length. And finally, side CD of square ABCD must be also equal to 45 units in its length. We know that the opposite sides of a rectangle are equal to each other. So in the small rectangle PTDC, side CD must be equal to the opposite side PT. But CD is 45, therefore PT must be also equal to 45 units in its length. So in the right triangle QTP, this angle equals to 90 degrees minus alpha, this angle equals to 90 degrees, and therefore this first angle must be equal to alpha. 1 plus alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees, that is the sum of degrees in a triangle. So in the next step, we prove that the green triangle OBD can go into this right triangle PQT according to angle side angle rule. So we have to prove that the green right angle OBD congruent to this right angle PQT according to angle side angle rule. So right angle triangle OBD congruent to this right angle PQT. First of all, those two angles are both equal to alpha and therefore they are equal to each other. So actually this angle BDO the green right angle OBD and it is equal to this angle, this is angle BPT. The right angle is actually this angle alpha is angle QPT, angle QPT. And again, I should found out that angle BOD in the green triangle OBD equals to angle QPT. In the right triangle PQT, they are both equal to alpha and therefore they are equal to each other. In addition, side BD of this green triangle OBD is equal to side PT of this right triangle PQT. And again, side BD of the green triangle equals to side PT of the right triangle QPT. They are both equal to 45 degrees in their lengths, therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees and therefore they are equal to each other. So actually this is angle OBD is the green right triangle OBD and it is equal to this angle. This is actually angle QTP. In the right triangle PQT. So again, I should found out that total the angle OBD in the right triangle equals to angle QTP in the right triangle PTQ. They are both equal to 90 degrees and therefore they are equal to each other. So total we prove that the green right triangle OBD can go into this right triangle QPT according to angle side angle rule. Okay. The green right triangle OBD congruent, this is the sign of congruent to the right triangle PQT according to angle side angle rule. That is to say, we can prove that those two angles and the side that is included between those two angles in this green right triangle OBD are corresponding equal to those two angles and the side that is included between those two angles in this right triangle PQT. And therefore those two right triangles can go into each other according to angle side angle rule. Okay, again, we can prove that those two angles and the side that is included between those two angles in this green triangle corresponding equal to those two angles and the side that is included between those two angles in this right triangle PQT. And therefore those two right triangles can go into each other according to angle side angle rule. And from the fact that those two right triangles can go into each other, we will graph that their corresponding sides must also equal to each other and the rest. This is to say OD equals to QP. OD is the hypotenuse of the green triangle OBD, and this equals to QP, this is the hypotenuse of the right angle PQT. So OD equals to QP, and OD equals to QP according to the rule that correspond in size and congruent angles are equal to each other. Those two right angles congruent to each other, the corresponding size must be also equal to each other, and then that is to say OD equals to QP. But we already found out that OD equals to 53. So we can write that OD equals to 53 units in its length. And for this equation, 53 equals to OD equals to QP, we will derive that QP must be also equal to 53 units in its length. So tangent QP equals to 53 units in its length. And we already found out that the area of square BCD equals to 2025 square units in its size. So we finished to answer the second question. In the next step, I will summarize the lecture. That is to say, we repeat on the solution of the first question, and then we repeat on the solution of this second question. In the first question, our task is to find out the length of side AB of this right triangle ABC. So in the drawing, we have a circle that is described by this right triangle ABC. Side BC equals to 40 units in its length. We also know that the radius of this circle equals to 4 units in its length. Again, our task is to find out the length of this side AB of this right triangle ABC. So first of all, we define the relevant points of this question with letters. We define the center of this circle, this point is point O. Likewise, we define the point of tendency of tangent AB with this circle, this point is point D. We define the point of tendency of tangent BC with this circle, this point is point D. And finally, we define the point of tendency of tangent AC with this circle, this point is point F. The next step, we join points O and E together by side line. Point O is the center of this circle, point E is the point of the circle itself, therefore O is the radius of this circle. The radius of this circle is equal to 4 units. The radius of E is equal to 4, the radius of E is known to point E, that is the point of tendency of tangent BC with this circle. And whenever your radius is known to the point of tendency, then tangent BC will be perpendicular to the radius EO. If BC is perpendicular to EO, it means that this circle equals to 90 degrees in its size, and this angle also equals to 90 degrees in size according to rule 1. Likewise, we join points O and D together by side line. All these, the radius of the circle is equal to 4. The radius of D is equal to 4. The radius of D is 1 to point D, that is the point of tendency of tangent AB with this circle. Whenever your radius is 1 to the point of tendency, then tangent AB will be perpendicular to the radius DO. If AB is perpendicular to DO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule 1. So inside the small quadrilateral ODBE, we have 1, 2, 3 right angles. The sum of right angles is 270 degrees, so 270 degrees plus the size of this fourth angle, so that must be equal to 360 degrees. According to the rule, it said that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth angle must be equal to 90 degrees in size. So inside quadrilateral DOEB, we have 4 right angles. Therefore, we can relate to quadrilateral DEOB is a rectangle. But you also know that the opposite sides of a rectangle are equal to each other. So in rectangle DOEB side DO must be equal to the opposite side BE. But DO is 4, therefore the opposite side BE must be also equal to 4 units in its length. Likewise, according to the symbol, in the same smaller rectangle DOEB side OE must be equal to the opposite side DB. But OE is 4, therefore the opposite side DB must be also equal to 4 units in its length. So in total, we should find out that quadrilateral DOEB is not a rectangle, but a square. Why? Because of the fact that all of its sides are equal to each other. Each side equals to 4. What is the length of this 970? EC is equals to BC minus BE. So EC equals to BC minus BE. EC equals to BC, that is 40, minus BE, that is 4. So in total, EC equals to 40 minus 4, that is 36. EC equals to 36 units in its length. The next step, we created all 2 in our drawing. So I'm pinching all 2. According to all 2, the lengths of 2 tangents from coming start point to a circle are equal. In the drawing, we have a circle. This is the coming start point P. For this coming start point P, we have 2 tangents to this circle, tangent PA and tangent PB. And according to all 2, they are equal to each other. That is to say, PA equals to PB. So can you create all 2 in our drawing? In our drawing, this is coming start point C. For this coming start point C, we have 2 tangents to this circle, tangent CA and tangent CF. According to all 2, they are equal to each other. That is to say, C equals to CF, but C equals to 36. Therefore, CF must be also equal to 36 in its length. Likewise, from this coming start point A, we have 2 tangents to this circle, tangent AD and tangent AF. According to all 2, they are equal to each other. That is to say, AD equals to AF. So if you define the length of AD as X, then AF must be also equal to X units in its length, according to all 2. The next step, we created the quadrilateral of this big right triangle, triangle ABC. According to the quadrilateral, in any right triangle, the square of the opponents equals to the sum of the squares of the perpendicular. So that is to say, in this right triangle ABC, it means that AC square, that is the square of the opponents, equals to AB square plus BC square. Repeat again, this right triangle ABC, according to the quadrilateral, AC square equals to AB square plus BC square. AC in total is X plus 36, therefore AC square is X plus 36 square, and it equals to AB square. AB is X plus 4, therefore AB square is X plus 4 square, plus BC square. BC is 40, therefore BC square is 40 square, that is 1600. So in total, if you want to know that X plus 36 square equals to X plus 4 square plus 1600. So here, open the brackets on both sides of the equation. So we found out that X plus 36 square equals to X square plus 36 square, that is 1296, plus 2 times X times 36, that is 72X. But on the other side of the equation, we have X plus 4 square. X plus 4 square equals to X square plus 4 square, that is 16, plus 2 times X times 4, that is 8X, plus 1600. Here we have X square on both sides of this equation, so X square gets cancelled. After we cancel X square in this side of the equation, we are left only with 1296 plus 72X, and on the other side of the equation, we are left with 16 plus 1600 is 1616 plus 8X. Here we subtracted 8X from the equation. So in this side of the equation, we have 1296, and 72X minus 8X is 64X. Equals to 1616, and 8X minus 8X is 0. So total, she found out that 1296 plus 64X equals to 1616. Here, subtracted 1296 from the equation. So here, 1296 will get cancelled, left only with 64X, while on the other side of the equation, we have 1616 plus 1296 equals to 320. So in total, we found out that 64X equals to 320. Here we divided this equation by 64 and finally found out that X equals to 320 over 64 is 5. So X equals to 5 units in its length. Our test is to find out the length of side AB. AB in total equals to X plus 4. AB equals to X plus 4, but X is 5, so AB equals to 5 plus 4, that is 9. So total, we found out that the length of side AB of this triangle ABC is equal to 9 units in its length. So finish to repeat on the first question, and the next step repeat on the solution of the second question. In the second question, we had two tasks. The first task is to find out the area of this square ABCD, and the second task is to find out the length of this tangent QP. So in the drawing, we have a quarter circle and a semicircle inside this big square ABCD. The quarter circle touch the semicircle externally at this point. So define this, the touching point, this point is point K. We also know that the radius of this semicircle is 17 units, the radius of this quarter circle is 36 units. Again, our first task is to find out the area of this square ABCD, and the second task is to find out the length of tangent QP. So first of all, we define the relevant points to this question with letters. We define the center of this semicircle, this point is point O. We define this point as point E. We define this point as point F. We define the length of this short line segment AB as X, and we define the length of this short line segment BF as Y. DF is the radius of the quarter circle, that is 36. OA is the radius of the semicircle, that is 17. Likewise, OE is also 17. Is the radius of the semicircle. Our first task is to find out the area of this square ABCD. So what is the area of square ABCD? The area of square ABCD equals to the length of one side squared, which is to say it is AB squared. According to the first method of calculation, the area of square ABCD equals to AB squared. AB in total it is 17 plus 17, that is 44 plus x. So AB is 34 plus x, therefore AB squared is 34 plus x squared. So according to the first method of calculation, the area of square ABCD is 34 plus x squared. According to the second method of calculation, the area of this square ABCD must be equal to BD squared. The length of one side square. So according to the second method of calculation, the area of the same square ABCD is equal to BD squared. BD in totality is y plus 36, therefore BD squared is y plus 36 squared. So according to the second method of calculation, the area of the same square ABCD is equal to y plus 36 squared. So we have two different equations for the area of the same square ABCD, equation 1 and equation 2. Therefore, we get the equation 3 that says that the area of square ABCD according to the first method of calculation, as we come to the area of the same square ABCD according to the second method of calculation. The area of the square ABCD according to the first method of calculation equals to 34 plus x squared, and must equal to the area of the same square ABCD according to the second method of calculation. The area of square ABCD according to the second method of calculation equals to y plus 36 squared. So total if you found out that 34 plus x squared equals to y plus 36 squared. Here to hold out of the equation, so here the root cancels the square, the left only with 34 plus x. Here also the root cancels the square, and the left only with y plus 36. So total if you found out that 34 plus x equals to y plus 36. Here we subtract the 34 from the equation, so here's 34 again cancelled, and this side of the equation left only with x, and on the other side of the equation we have 56 minus 44 is 2, so total expression equals to y plus 2. So total if you found out that x equals to y plus 2. Here you can implement rule 10, area external is between the semicircle and the quarter circle at point K. That is to say, the semicircle touches the quarter circle externally at point K. Therefore, we can implement rule 10. So I can implement rule 10. According to rule 10, if two circles touch each other externally, then the straight line that connects the circles together passes through their touching point. So in the drawing, we have those two circles that touch each other externally at point P. The center of this circle is at point O. The center of this circle is at point M. And the straight line that connects the circles together, of course, the straight line OM. According to this rule 10, the straight line OM must pass through their touching point, that is point P. And the straight line OM must pass through point P, that is their touching point. OPM is one straight line. Again, OPM is one straight line according to this rule 10. So if OPM is one straight line, it means that OM in total must be equal to OP plus PM. So the center of this semicircle is at point O. The center of this quarter circle is at point D. The straight line that connects the circles together is of course the straight line OD. According to rule 10, the straight line OD must pass through point K, that is the touching point. And indeed, you see that the straight line OD definitely passes through point K, exactly according to rule 10. according to OT, we know that OD total equals to OK plus KD. OD equals to OK plus KD. So OD total equals to OK, this is the radius of the semicircle, that is 17, plus KD. KD is the radius of the quarter circle, that is 36. So total, if you found out that OD equals to 17 plus 36, that is 53. OD equals to 53, everything is left. So the next step we implemented Quadratus on this given item ODB. According to the Quadratus on this given item OBD, OD squared, that is the square of the opponent, equals to OB squared plus D squared. Again, OD squared equals to OB squared plus BD squared. OD squared, that is the square of the opponent, equals to BD squared plus OB squared. OD equals to 53, therefore OD squared is 53 squared, that is 289, plus OB squared. OB is 17 plus x, therefore OB squared is 17 plus x squared, plus BD squared. BD in total is y plus, BD in total equals to y plus 36, therefore BD squared is y plus 36 squared. So total, we should found out that 2,809 equals to y plus 36 squared plus 17 plus x squared. We only found out that x equals to y plus 2. Therefore, can you substitute x by y plus 2? So 17 plus x is 17 plus 2 plus y. This is to say it is 19 plus y. Therefore, 17 plus x squared is 19 plus y squared. Here we have, we open the brackets on this equation. So here we have 2,809 equals to y plus 36 squared. Y plus 36 squared equals to y squared plus 36 squared, that is 496, plus 2 times y times 46, that is 72y. And we found out that 17 plus x squared equals to 19 plus y squared. So in total, we found out that 2,809 equals to, here we have, open the brackets, this expression, 19 plus y squared equals to 19 squared, that is 361, plus y squared, plus 2 times y times 19, that is 38y. So, in total, we found out that 2,809 equals to y squared plus y squared is 2y squared. And we also 1,296 plus 361 is 1,657. And we also 38y plus 72y equals to 110y. So total, if you found out that 2,809 equals to 24y plus 1,657 plus 110y. Here subtracted 8,009 from this equation, so in this side of the equation we have nothing, that is to say 0. But on the other side of the equation we have 2y squared plus 110y, and 1,657 plus 2,809 equals to 1,752. So in total, if you want out that 0 equals to 2y squared plus 110y, 1,152. Here we divided this equation by 2. If you found out in total that 2y squared over 2 is y squared, 110y over 2 is 55y, and finally 1,752 over 2 is 1,576 equals to 0 over 2 is 0. So in total, if you found out that y squared plus 55y minus 576 equals to 0, this is a quadratic equation. And the general formula for a quadratic equation is as follows. Ax squared plus bx plus c equals to 0. This general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus 1 square root of b squared minus 4 times c times 0 to a. So we find out the value of x according to this formula. Now a specific quadratic equation, that is to say y squared plus 55y plus 576 equals to 0. The variable that we are looking for is y, so x equals to y. Coefficient A equals to 1 unit in step, coefficient B equals to 55 units in step, coefficient C equals to 1,576 units. So we have all the data that is needed in order to find out the value of y, that is the variable that we are looking for. This quadratic equation, we just have to put the data inside the general formula of x, and this way we find out the value of the values of y, because y might have two solutions. So we did it when we found out that x equals to y, so we substitute x by y equals to minus b. B is 55, therefore minus b is minus 55, plus minus go to b squared. B is 55, therefore b squared is 55 squared, that's 1025, and we also minus 4 times a. So a is also minus 4 times 1 is minus 4 times c is minus 576. So minus 4 times 500, minus 4 times minus 576 equals to 2304 divided by 2a. A is 1, so 2a is 2 times 1, that is 2. So in total, we found out that y equals to 155 plus minus, and 325 plus 2304, in total it equals to 5,329 divided by 2. So y equals to 155 plus minus, let's go to 5,329 is 73 over 2. So here we have two solutions that are possible for y, and so going to count only the positive solution for y. For y, because y is the left of bt of bf, so therefore it must be positive number. So the positive solution for y is as follows. Y equals to minus 55 plus 73 over 2. Minus 55 plus 73 is 18, and 18 over 2 is 9. So if we found out y equals to 9 units left, and when we found out that x equals to y plus 2, therefore x equals to y, that is 9 plus 2. 9 plus 2 is 11. So if we found out that x equals to 11, and y equals to 9. Again, x equals to 11, and y equals to 9. Our first test is to find out the area of this curve square ABCD. The area of square ABCD equals to AB square. AB square, but AB in total is 34 plus x, therefore AB square is 34 plus x square. So in total, we found out that the area of square ABCD equals to 34 plus x square. But x is 11, so 34 plus x is 34 plus 11 square. 34 plus 11 is 45. So this expression equals to 45 square. 45 square is equals to 225 square inside. So we found out that the area of square ABCD is equal to 225 square meters in its size. This is the first part. The next step, we found out the length of this tangent QP. In order to find out the length of tangent QP, we define this angle as alpha, so the angle diagonal OBD, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first angle must equal to 90 degrees minus alpha. 1 equals 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees, and this is the sum of degrees in the angle. Therefore this first angle must equal to 90 degrees minus alpha. We have the radius decay of the quarter circle is down to point K. This is the point of tendency of tangent PQ with this quarter circle. And whenever you have a radius that is down to the point of tendency, then tangent PQ will be perpendicular to the radius KD. PQ is perpendicular to KD. This is the angle equals to 90 degrees, and this angle also equals to 90 degrees according to all 1. So in this form, again, diagonal QKD, this angle equals to alpha, this angle equals to 90 degrees, and therefore this angle must equal to 90 degrees minus alpha. 1 plus 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. This is the sum of degrees in a triangle. So this first angle must be equal to 90 degrees minus alpha. So in the next step, we did the construction, that is to say from point P, we do perpendicular on BD, and from point P, we do perpendicular on BD. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We find the touching point of the perpendicular from point P and BD, this point is point T. By doing this construction, we created quadrilateral PTDC. So quadrilateral PTDC, those two angles are both right angles because there are two angles of square ABCD. This is the other angle from the construction. So this quadrangle PTDC, we have 1, 2, 3 degrees. This angle equals 200 degrees according to our construction. The sum of 3 degrees is 270 degrees, so 270 degrees plus the size of this fourth second, to that must equal to 360 degrees. According to the rule, it says that the sum of degrees in any quadrangle is equal to 360 degrees. Therefore, this fourth second must equal to 90 degrees in its size. So instead of quadrangle PCTD, we have 4 degrees. Therefore, we get quadrangle PTDC, so F degrees. AB in total equals to 34 plus x. X is 11, so 34 plus x is 34 plus 11, that is 45. So all the other sides must also equal to 45 units in diameter, because of the fact that ABCD is a square. So this side BC is 45, side CD is also 45. You know that the opposite sides of rectangle equal to each other. Say CD equals to PT, but CD is 45, so for PT must also equal to 45 units in there. So we have here PT equals to 45, and in this triangle PQT, this is the right angle, this angle equals to 90 degrees minus alpha, therefore this first angle must equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees, that is the sum of degrees in a triangle. Therefore this first second must equal to alpha. In the next step, we prove that the green right triangle OBD can go into this right triangle QPT according to angle side angle rule. And again, we prove that the green right triangle OBD can go into this right triangle QPT according to angle side angle rule. So why the green triangle OBD can go into the right triangle QPT? First of all, those two angles are both equal to alpha, and therefore they are equal to each other. In addition, BD equals to PT equals to 45. And finally, those two angles are both equal to 90 degrees, and therefore they are equal to each other. So if you found out that all the figures of the green triangle OBD are corresponding equal to all the figures of this right triangle QPT. Again, we found out that the green triangle OBD can go into the right triangle QPT according to angle side angle rule. Again, because if you found out that the green right triangle OBD can go in, this is the same can to the right triangle PQT according to angle side angle rule. That is to say, we should prove that those two angles and the side that is difference between those two angles in this green triangle OBD are corresponding equal to those two angles, and the side that is difference between those two angles in this right triangle QPT. Therefore, those two right triangles can go into each other according to angle side angle rule. Okay, again, we have those two angles, and the side that is difference between those two angles in this green triangle corresponding equal to those two angles, and the side that is difference between those two angles in the triangle PQT. Therefore, those two right triangles can go into each other according to angle side angle rule. Therefore, we found that they can go into each other. We know that side OD equals to side QP. OD equals to QP. Why OD is the corresponding side of QP? Because OD is the opposite of the green triangle. Likewise, QP is also the opposite of triangle QPT. Therefore, OD and QP are corresponding sides. But we only found out that OD equals to 55. And I think that OD equals to 55, OD equals to 53. OD equals to 53, so can I get that OD equals to 53, and for this equation 53 equals to OD equals to QP, we derive that QP must be also equal to 53 units in its length. And again, if you found out that tangent QP equals to 53 units in its length, and we found out that the area of this square vicinity is equal to 225 square units in its size. And again, QP equals to 53, and the square vicinity equals to 225 square units in its size. Okay, thank you very much.